Hello, everyone. So today we will discuss chapter number five. Chapter number five is all about TCP/IP protocol. So if you remember, in the previous video, we have discussed the OSI model, and I believe everybody is clear about OSI model. What's the difference between OSI versus TCP/IP model? So OSI model is basically a reference model, while TCP/IP protocol is the practical implementation of OSI model, like the customized form of OSI model, the one which we use. So in this video, in this chapter, we will be talking about TCP/IP protocol, the working of TCP/IP protocol. We will discuss the protocols, like different protocols which work on TCP/IP protocol. Basically, the TCP/IP protocol itself is nothing. It's basically a suite of protocol. Like TCP/IP protocol is basically the suite of protocol. Like there are many protocols inside the TCP/IP protocol. Okay. And then we will discuss the SYN protocol as well, which is also a part of the TCP/IP protocol. So before we jump into the TCP/IP protocol, let's do step by step. Let me break down everything in simple words. Firstly, we will discuss what a protocol is. How do you define a protocol? Protocol is basically the set of rules for data communication. I'm talking about in networking. In networking terminology or network terms, the protocol is called set of rules for data communication. So set of rules for data communication between devices or between computers. And for example, if you want to design a network or if you want two computers to communicate over internet. So let's say you have a computer one, and let's say there is another server, which is, for example, ggc.edu. So if these two computers are located distant apart, for example, this is under a local area network, and this is, for example, located over internet. All right. So for example, if you want these two computers, which is a PC and a server, to communicate with each other, you need to use a protocol called TCP/IP protocol. And what is TCP/IP protocol? It's a suite of protocol. So just like, for example, if you got admission to a school, let's say you got into GGC. If you want a bachelor's degree in IT, there is basically a rules. Like there are some rules, some protocols. Like you have to, for example, earn 123 credit hours. All right. And how you can get 123 credit hour, there are certain courses that you have to take. For example, you need to take ITech 3300, ITech 3100, etc. For each particular course, you need to get at least 70% points in order to pass the class, something like that. Are you getting the point? So what exactly all these things? These are basically the rules, the protocols set by organization GGC. Exactly the same way, if you want two computers to communicate over internet, these two computers, they have to use TCP/IP protocol. And TCP/IP protocol, it includes several other protocols inside it. All right. So let's get started with the basics and working of TCP/IP protocol. I'll try to explain in simple word, as simple as possible. So first of all, what is TCP/IP protocol? TCP/IP protocol is basically a suite of protocols which allow two or more computers to communicate over the network. Over the network, two computers, if they want to communicate, I'm specifically over the internet. If two computers want to communicate over internet, they need to use TCP/IP protocol. And TCP/IP protocol is mainly responsible for message encoding, data encapsulation, and the delivery of the message as well. And it defines what would be the size of the packet as well. So all these instructions, all these rules are defined in TCP/IP protocol. All right. So now let's get started. What exactly? This is just a basic introduction of TCP/IP protocol. Now let's talk about what exactly the TCP/IP protocol is. Again, as I told you guys, TCP/IP protocol is basically the practical form of the reference model OSI model. So OSI model is a source of inspiration. From OSI model, we have created our protocol called TCP/IP protocol, so we can allow two computers to communicate with each other. All right. So unlike the OSI model, in TCP/IP protocol, we have four layers. Again, if you see the the lowest layer is going to be layer number 1, layer 2, layer 3, layer 4. So we have 4 layers. This is the stack of TCP/IP. It has 4 layers, just like OSI model where we have 7 layers, but here we got 4 layers. But all those the activities like which we discussed in the OSI model, we will get them done by using these 4 layers. So let's try to understand all these layers, like what happens to application layer, transport layer, internet layer, and network layer. Let's try to understand with example. Let's take a practical example. So for example, let's say, let me design us. So that's our scenario where if you see, this is our computer 192.168.1.1. This is our IP address, and that's our MAC address, right? So we want to access, for example, ggc.edu. So we are connected with internet through our ISP, and we have a router as well. As you know, router connect 2 or more local area networks. Okay, so router connect 2 or more networks. So our network is connected with ISP, and ISP gets it connected with the internet, and that's basically where ggc.edu is located. For example, that's the server, right? Now, how we want to access, for example, ggc.edu web page on our computer. So we will forward this request. We will form a frame, a packet or a frame, and how this particular frame will go to ggc.edu, how they will respond us back. So let's see with this particular example with the stack of TCP/IP protocol. So the first point of contact, like right here, we are on our PC, for example, we are on this computer. On this computer, first of all, the first point of interaction is going to be our application. Application mean on application layer, we have the web browser. So whatever you can do on your web browser, it gets it done by using a specific protocol. Let's say if you want to visit a website, you want to just fetch the web page. So we will use HTTPS protocol. We're going to talk about it, all right? So let's say I just want to visit this web page. I just want to get to ggc.edu and I want to fetch the request. So my request is I just want to fetch the web page, right? So what's going to happen? On my web browser, on application layer, I will create a request. It is called HTTP header. So I will create a HTTP header, which is basically my request. It will have a data. Right now, I'm just skipping the data for ease. I'm skipping the data for now. So what is HTTP header? HTTP header is basically a request. So what is HTTP header? This particular header mean it is basically request. I mean, there are different HTTP methods. Like for example, you can use HTTP GET method. You can use HTTP POST method. There are plenty of methods I'll show you in the class. Okay, those methods are typically used in order to take input, for example, and things like that. So for example, I just made a request. I want to visit this web page. So on application layer, it will create a HTTP header. Got it? Now, HTTP is a protocol. On application layer, for example, if you want to download something, we have a protocol called FTP. If you want to send an email, the protocol is SMTP. Are you getting the point? We will discuss all these protocols in a bit. But right now, let's say I want to visit this particular website. If you want to visit the website, the protocol is HTTP. So what's going to happen? I have created a HTTP header. Now, this particular header is just a request. There is no information, like we don't know where this packet is going to be transported, nothing like that. So request is, HTTP header says request I want to visit ggc.edu. That's it. Okay. Now on application layer, we have the DNS and all that stuff running, like request ggc.edu. There is a protocol called DNS which runs on application layer. It will basically provide you the IP address and all that details. But let's move on. So we have created HTTP header. Now this particular small frame or packet, whatever you want to name it, will get to the transport layer. On transport layer, what we do segmentation, like divide the large data into small segment. Plus we add the port numbers. Port number, assume that this port number is basically like a door. Each particular protocol operates on a specific port. Got it? For example, if you're using HTTP protocol, HTTP. So for HTTP, there is a port number 80 reserved for HTTP activities. If, for example, you are using FTP protocol, port number is 20 or 21. These two ports are reserved. You can use 20 either or 21. Okay. So now what's going to happen when this particular packet will get to transport layer? Transport layer will add another header, which is called TCP header. For example, I'm assuming that it is basically a TCP packet. I'll explain you And we already know that the difference between TCP and UDP. If it would be a UDP packet, it will add a UDP header. So TCP header, what is TCP header? TCP header at transport layer. So here we will make a request at transport layer. It will add TCP header. What is TCP header? TCP header mainly add source plus destination port numbers, like from where this particular packet will go and at which particular port the packet will be received. And this HTTP header will carry forward. It will come from down. So HTTP header will still right here. So now we have request. Now we have the source plus destination port numbers. And again, these port numbers are based on which protocol we are using. Okay. So now in this case, we have the port 8080. 80 source, 80 destination. All right. Now this particular packet will get to the next layer. Okay, something like that. We will have HTTP header as it is. HTTP header as it is. We will have TCP header as it is, which will have source and destination port numbers. Now it got to the internet layer where we have over networking devices like routers and these kind of devices. Now it will add a header which is called IP header. Now IP header, what would be inside the IP header? IP header will add source plus destination IP addresses, like your IP address, which is 192.168.1, and destination IP address, which is the 1.1.1.1. So IP header will add source and destination IP addresses. All right. Now the last is basically this particular packet will get to the network layer. Now network layer is where, let me just make it slightly compressed form because every other header is going to be added. So we will have HTTP header here. We will have TCP header here. We also have the IP header. And as you know, IP header is basically source and destination IP addresses. And network layer will add Ethernet header. Now Ethernet header, what it's going to add? So Ethernet header will add source plus destination MAC addresses. Remember the physical address, the network interface card address, source plus destination, like your MAC address, my MAC address is AAA, and the destination MAC address. Now here is a question. Do you think while sitting at ggc.edu, right, within the local area network, we can find the MAC address, which is GGG of ggc.edu? No, we know the IP address by the routers. They will provide IP addresses. Remember the DNS? The DNS, we discussed the DNS. It will provide us the IP address of destination. Source IP address, we already know that. Assume that no NAT has been applied. Now question is, how do we find the destination MAC address? The answer is very simple. The destination MAC address is not going to be your final destination MAC address. Okay. The destination is going to be your router's MAC address, your gateway MAC address. All the time we will add the gateway MAC address. We don't enter in the Ethernet header the MAC address of final destination. So now what's going to happen? This particular packet, this is basically our TCP packet. There are a few more things we need to add up here. I will explain you when we proceed to the next part. I'll show you. I will create a complete TCP packet for you in a bit. Now what's going to happen? If you guys see, we will send this particular packet to our router. So router, again, because destination, as you remember, for local area network communication, we need to know the MAC address of each other. For wide area network communication, we need to know the IP addresses of each other, the IP addresses. So what's going to happen when this particular TCP packet will get to the router? Router will open the packet, because it will open and see the Ethernet, because open the Ethernet header, because this is, and check out the destination, because destination is for this particular router. So what's going to happen? The router will check out the destination IP address, and then for the destination IP address, it will use the protocols like RIP, router information protocol. Remember the hop count one, which uses the hop count, or OSPF protocol, open shortest path first, and then it will pack the protocol again, like make the packet again and forward it. You guys can see here the next in the line is this particular router, the next this gateway. So now what's going to happen? Firstly, packet will get to this, then this particular path, it will follow this path and get to this particular router, because in this Ethernet header, destination MAC address, next destination MAC address is going to be MMM. And then what's going to happen? This router will find out where this IP address is located, like this one, the destination, and then deliver that particular packet to this particular device by putting the MAC address of that by using the switch. I hope everybody got this idea. So this is the way how the communication occurs, like how the TCP IP packet it basically get formed. We'll discuss the application layer in detail and transport layer and all those details. But this is basically the working of the TCP IP protocol. Let me just give you one more example by keeping the same IP addresses. This is source IP address, source MAC address, destination IP address, and MAC address of my destination. Now I'm going to actually put the IP addresses here, okay, and to design the TCP packet by using this layer. Let me just take a blank page here. Let's see if I can add a blank page. Let me go back here and let me take this page right here. Okay, so let's see. Let's take a simple example. Again, I'm going to actually take the 4 layers. All right, my highest layer is application layer, where I have the browser and all those application through which user can directly interact with the internet. Transport layer. Next is my internet layer, and my lowest layer is the network layer, which is responsible for network activities plus the physical, like data link layer and basically the physical layer. All right, so my application layer, let's say again the same thing. This is the computer, and let's say IP address is 192.168.1.1, MAC address 1.1.1.1. It is connected to a router. Router MAC address is RRR. Router is connected with internet. Again, I'm skipping the ISP part here. And it is connected with another router. And the path is, let's say this is one, what was that? We use the same name. Okay, MMM. So let's use the MMM. And for example, this is basically where the GGC server is, ggc.edu, IP 1.1.1.1, MAC is GGG. All right, so let's see how, let's say we are sitting right here, and now this time we want to download the data. We want to download a file, right? So if you want to download a file on application layer, we will create a header, and that particular header is going to be FTP header. We want to download a file transfer protocol, FTP header. Okay, we want to download it. Then when this packet will get to the next layer, which is transport layer, let me just make it small so we can have the better room for next layer as well. So when this particular packet will get to the next layer, transport layer, it will add TCP header, and TCP header, what we're going to add? Source and destination port numbers. So here the port number is going to be, let's say the port number, the source port number is, for example, 20, and destination port number is, for example, 21. Okay, because we use 2021 both for FTP. So let's use source and destination 2021. Why? Because we are using FTP protocol this time. That's what's gonna add. And again, FTP header will be right here. FTP header would carry forward. Next, what's gonna happen when this particular part will get to internet layer? So once it will get to internet layer, FTP header as it is, TCP header would be as it is, and here we will add IP header. Now this IP header would be source IP. Okay, here we will have source IP and destination IP. Now what is source IP address? Source IP address is this. So I'm gonna put here 192.168.1.1. Destination IP address 1.1.1.1. All right. And now let's move on. This particular packet has full information. It has the information about source destination, it has the port, source and destination port numbers, all the details is good, but still we need to know the MAC addresses, like how this packet physically travel, because physically we need to know the MAC addresses. So now this will become the frame. So now the packet will be turned into frame. We will have FTP header, TCP header, we will have IP header, okay, and all these details are right here. I'm not putting it down here. Now it will add basically Ethernet header, and Ethernet header is source MAC address, D destination MAC address. So what would be the source MAC address? It is basically, oh sorry, the source MAC address is not 111. Let me just make it AAA, for example, AAA. So source MAC address is AAA, and destination MAC address we don't know. Like we don't know the final destination MAC address, right? So what we're gonna do is we will basically put the MAC address, destination MAC address is the gateway MAC address. Gateway mean the routers. The router MAC address is RRR. Now what's going to happen? This is basically our TCP packet. Again, this is not the complete TCP packet. It does have the other information that we need to add. But let's see what's going to happen. So now this particular frame, like this particular frame will get to the router. Now router will open up this particular frame. Router will open it up, check out the IP address. And router found the IP address 1.1.1. Router find the route from here and see, okay, I can forward this to this router and this router can deliver it to the final destination. Router will pack it again. So this particular packet at the router will find the IP address of final destination and pack this packet again. Now this is how this packet will look like at this point. At this point, FTP header would be same, TCP header would be same, IP header would be same, like everything else would be same. Now Ethernet header would be modified. Now this Ethernet header would have source MAC address is exactly the same, which is AAA, and destination MAC address is going to be the next router in the line, right, where the packet would be delivered. So packet would be delivered, for example, MMM. Got it? Now once this packet would be delivered here, they will again open it up. Okay, they will open it up, find the IP address, and then pack it back. When this router will get, this packet will get to this particular point. So the MAC address is going to be, then it will have the final MAC address, which is going to be GGG. Sorry about that. GGG. Everybody got it? So at this point, the MAC address is going to be the next router. At this point, the MAC address is going to be, the destination MAC address is going to be RRR. At this point, the destination MAC address is going to be the next router in line, which is destination MAC address is MMM. At this point, the router MAC address, it will get the final or real MAC address of the destination. I hope it clarifies your point. If you will have still have any questions, you can always tell me. If you want to better understand that, let's take a simple example. Let's say you are basically writing a letter. So you wrote a letter. Let's say you wrote a letter. After you write the letter, you need to write down your name to, like your name from the name of your friend to your name from your friend. Then this is the transport layer. You wrote a letter, transport layer, your name, your friend's name, and then when it get to the internet layer, we need to actually put the addresses. You will put the address. Let's say it's going from Texas to, let's say, New York, right? You will put the exact address. Then network layer, do you think they will deliver your letter directly from Texas to New York? No, they will basically firstly deliver to their post office, from this post office to next post office, and then eventually they will deliver it. So this is basically the phenomena or the working of a TCP IP protocol. I hope it clarifies this example, give you better understanding about why we don't have the destination MAC address in advance. All right, so let's move on and let's talk about application layer. Let's see what sort of what we do on application and what sort of protocols run on application layer. So on application layer, we have all the application. Our user can directly interact with the application. So basically, application layer contains. So let's see. All right. So let me get okay. So application layer contains end user applications. End user applications. End user application means through which user can directly interact. For example, let's say browser is the biggest example. Browsers, web applications or web apps or mobile apps, etc., through which user can directly interact with internet. That those applications are basically run on application layer. Now, whatever you can do on the browser, it gets done through a specific protocol. Specific protocol. Let's say if you want to download application, you want to send email, there is a specific protocol for that, right? So let's see which sort of protocols run on your application layer. The most important protocol, the first protocol that you may already heard of, it's called HTTP. HTTP stands for Hyper Text Transfer Protocol. Hypertext Transfer Protocol, one of the most commonly used protocol. HTTP protocol, it runs on the port number 80. Port 80. For example, if you remember the lab number 1, if you turn on your port 80, your system will turn into a web server. So for example, if you install a web service application, your port 80 must be open. Typically, there are different method of HTTP. Let's say if you want to take input from user, there are different methods. One of the HTTP method is get, another method is post. In security class, you will understand the difference between post and get. I will explain you in the class if you will have any questions. Typically, we use HTTP protocol to control the page, web page. This is the web page display, like how that particular page will display on your screen, or for example interaction with the web page. Interaction, so user interaction with the web page, it controls the data flow. Next we have the HTTPS. HTTPS is exactly the same thing, but S is for secure. So secure hypertext transfer protocol. Hypertext transfer protocol. Hypertext transfer protocol, secure hypertext transfer protocol is exactly the same thing. Like you just view the web page, control the interaction, same methods, but data goes in an encrypted form. Encrypted form. Okay, data goes in an encrypted form. It mainly use a method which is called SSL. SSL, secure socket layer. Socket layer. Okay. And for example, if you are using or accessing a website which is ending up with HTTPS, so data goes in an encrypted form, nobody can see what you have transmitted. Okay. And method, typically it's SSL. HTTPS port is 443. So port 443 of your computer is a logical port, by the way. In a computer, if you guys go back here, like, because we had source and destination port numbers, by the way. So source and destination port numbers are basically to 16-bit address. So 16-bit MAC address of each particular one. So that's basically what the HTTPS is. Everything else is exactly the same, but data goes in an encrypted form, and we use here asymmetric encryption. Asymmetric encryption. If you please remind me in the class, I'll show you the keys and all those stuff. Next protocol is FTP, which runs on application layer. FTP it stands for File Transfer Protocol. File Transfer Protocol. And this particular protocol runs on the port number 20 or 21. These two ports are reserved for that. And this protocol it's a standardized protocol for uploading and downloading. Uploading and downloading. So uploading and downloading, moving the data, so all those things, like for transferring the files, transfer files, all these things are basically, we get it done by using FTP protocol. Then we have a DNS protocol, DNS, domain name system protocol. And this particular protocol, what it does, it connects users. We have already discussed the DNS, by the way, to websites using domain names. Using domain names instead of IP addresses. Okay, so we have a port reserved for that, and that port is port 53. So port 53 reserved for DNS activities. Okay, next is the SMTP protocol. It stands for Simple Mail Transfer Protocol. Simple Mail Transfer Protocol. And this particular protocol, it runs on the port number 25. And what are the tasks? It basically, if you want to send an email, so you can transmit email. It is responsible for transmitting emails over internet, and also it controls the formatting of email, the formats of email. Okay. Another email protocol is called Post Office Protocol, POP. So this particular protocol, it stands for, so POP3 stands for Post Office Protocol. And this particular protocol is responsible for downloading emails from email servers to your device, to your local device. So POP3 protocol is typically, it's becoming very common nowadays, and we use a port number. So port number 110 is reserved for POP3. Next, we have another protocol which is called IMAP. Again, this particular protocol is used for the emails. It stands for Internet Message Access Protocol. Internet Message Access Protocol. And this protocol is also, what it does, it basically used for synchronization of emails. What does it mean? For example, let's say you have, for example, a computer, a laptop, and this is, for example, hotmail.com. So let's say you have a hotmail.com. This is your cell phone, and for example, that's your computer. So let's say if you read the email on the computer, it will mark read on your cell phone as well. Let's say, for example, you got an email and you read the email on your computer. When you go back on your phone, you will see that email will be marked as read. So who controls all these synchronization? IMAP. Then we have another protocol, very common protocol. This particular protocol is typically used for to log into the remote servers. It's called Telnet. It has been obsolete, by the way. We don't use it anymore because it was insecure one. So it allows insecure. We in fact use SSH, by the way, nowadays. Insecure log on to remote servers. So people typically use VPN. They have started using VPN instead of the Telnet protocol. So Telnet protocol, it runs on the port. So the port number is 23. Port is 23. So reserved for Telnet. Okay. So all these protocols run on application layer. Beside these, there are a few more protocols like SSH, which is Secure Shell. It stands for Secure Shell. So Secure Shell or SSH protocol, it runs on your port number 22. Okay. Why we use it? This particular protocol is again allows secure or encrypted communication between remote servers. Then we have the dynamic host configuration protocol, DHCP. We already know that. We have discussed what exactly it does. Allows the IP addresses, allows automatic IP addressing. The port number is the one which you need to know. It's the port 67 or port 68. So you need to turn on these ports if you want to offer a DHCP or if you want to install a DHCP server. SNMP, simple mail, sorry, the it's called simple network management protocol. Simple network management protocol. So it runs on the port 161. So SNMP, it's typically used to basically pass the network messages. SNMP protocol. So typically we use this protocol is basically used for managing and monitoring the network connected devices with specifically a local area network. So we have a dedicated port for that, 161. Then we have a RDP, remote desktop protocol. Remote desktop protocol. And this particular protocol is typically used in Microsoft Windows, okay, and to remotely access a computer. So port number 3389 is reserved for that particular task. So all these are basically different protocols which can do different activities. There are many other protocols as well. So now I believe everybody got the idea. TCP/IP protocol is a suite of protocol. You guys can see all these protocols are part of TCP/IP protocol, okay. Now let's see. So if you want to do any sort of activities, you'll use that particular protocol and then make a header, and then it will go to the transport layer. Now let's see what happens on to the transport layer. What typically we do on transport layer. We already know that on transport layer we basically do the segmentation. So on transport layer, on the transport layer, what typically we do? We encapsulates the data into segments, and we also add port numbers, remember, numbers, the source and destination port numbers. So let's say you got 100 bits to transmit. So what transport layer is going to do? Transport layer will make the 4 segments. Let's say segment 1 to 25 bits are right here. This is going to be segment number 1. 26 to, for example, 50 is right here. 51 to let's say 75 is here. 76 to 100 bits are located right here. So this is page number 1, page 2, page 3, or whatever the name you want to give. Okay, segmentation. Now this transport layer will define whether these packets will be transmitted using TCP protocol or UDP protocol. TCP, as you know, transmission control protocol. It is connection oriented. Remember that connection oriented. And UDP is basically user datagram protocol. User datagram protocol, which is connectionless. Remember? So let me just explain you what is the TCP protocol, TCP packet, because over internet we have the packet. This sort of packet would be either TCP packet or it could be a UDP packet. There is no other third type of the packet. Now let's try to understand this, because in TCP we basically use a 3-way handshake process. So what happens? Let me explain you. This is basically the SYN protocol. It's called SYN protocol. Now what's going to happen? For example, let's say we have this computer 1 wants to talk to, for example, ggc.edu. So for example, these two computers want to communicate. So before this computer 1 will start communication, the exchanging the data, the first thing is it will basically send a packet. Again, it's a TCP packet, but again, just like the whole packet, remember the whole TCP packet? It will send the whole TCP packet, like it will have the header, like HTTP header, and that header is just a request. Okay, it will basically have a TCP header, the same thing. It will have an IP header, it will have an Ethernet. Remember all that? So it will basically send a header with no data inside. So there will be no data. But remember I told you guys this particular packet is not complete. Like this is not complete packet. This is not a complete TCP packet because we were missing of the data. We were missing of the flags as well. Okay, these flags are very important to understand because these particular flags tell the receiver like what sort of data you need to expect inside this packet or the frame. So if I just show you guys here, let's say this is how TCP packet typically looks like. Let's say this is a TCP packet. In the TCP packet, we will have again the same thing. Let's say this is my data. For example, this is the data. This is my TCP, let's say HTTP header. Let's say this is TCP header. I'm just putting it down here. And let's say this is my HTTP header. Okay, so like this thing right here, this HTTP header, FTP header, TCP header, this is TCP header. Let's say I have IP header, plus I will have the Ethernet header. Right? Now, beside this, we have 6 different type of flags. There are 7 flags, by the way, 6 different types of flags here. So flags basically tell the receiver what sort of packet it is. Flag can be SYN, SYN flag. Like SYN flag is basically the SYN protocol. Like, are you up or not, and things like that. We're gonna discuss that. Another flag can be acknowledgement. Let's say if you send a packet, if it is a response of something, acknowledgement flag. Another flag is urgent. If the data is urgent, you can flush up whatever the data you have in your RAM and take this data. Reset, for example, if the server is down or the remote computer is down, they will send a packet with RST reset. We have fin flag as well. Another flag was push flag. So these sort of flags are basically appended, and this is now a full TCP packet. Okay, so we will send this whole TCP packet like this right here. We will send this TCP packet here. Okay, but with only one flag on, which is SYN flag. It means it will tell, I mean, this is the indication that they are trying to ask you, are you up or not? So what's going to happen? You will send a request with SYN flag on, like the whole TCP packet, like this whole TCP packet, this thing, with only this flag on, rest of the flags will be 000. Got it? So we will send this information. So, okay. If, for example, the server is on, they will respond you back with another TCP packet, like the whole packet with 2 flags on, SYN flag and ACK flag. Got it? Once you receive SYN ACK, you will respond back to them with a flag on, ACK flag, acknowledgement. Like everything else will be same with the acknowledgement flag, like I got it. Now, once this is 1, 2, 3, the 3-way handshake got completed. Like, again, let me repeat. You will send a TCP packet with a SYN flag on and ask them, are you up or not? If they respond you back, if they are up, they will respond you back with SYN acknowledgement. And once you got the SYN acknowledgement, like the flag, the TCP packet with SYN and acknowledgement flag ons, you will respond back with the ACK flag on. After that, the bidirectional communication will start. Bidirectional communication will start. And once the bidirectional communication will finish, you will send a TCP packet with fin flag on. Like this is the finish flag which I was talking about, the fin flag on. Rest of the flag would be 0. And once they got it, they will also respond back with the fin flag, like a TCP packet with a fin flag on. So the first 3 handshakes, if you guys see, this is basically called SYN protocol. I hope everybody got it. Whenever you send a TCP packet, we make sure, or we establish the SYN protocol first, and then we start sending out the TCP packets. This is why we call it TCP is a connection oriented. Why? Because it runs SYN protocol before starting communication. I hope it makes sense to everybody now. And on the transport layer, we do the encapsulation. We basically add the port numbers, plus we also add the initial sequence number as well. Like for a sequence number is, so basically the packet can be reconstructed at the receiver end. So it's called ISN. ISN, it also added ISN, initial sequence number, initial sequence number. And this initial sequence number is important. It's basically a 32-bit sequence number, which basically why we added typically because we broke the data into 4 packets. So receiver need to rearrange them. So it allows the receiver to reassemble the packets. So the packets can be reassembled because if you're using a wireless channel, there is no guarantee that these four packets will go in the same sequence. Okay, there is a possibility receiver may receive packet number 4 first, then packet 1, then packet 3, then packet 2. Then receiver, if receiver knows the packet numbers or for example the bit numbers, then receiver can rearrange them. And how receiver will get it? By using ISN. So transport layer does three things: encapsulate the packet segment, add the port numbers, and number three, it basically add the sequence number, initial sequence number. Now the last agenda item is the internet layer. What typically we do on internet layer, we mainly add the source and destination IP addresses. We add source plus destination IP addresses. So source and the destination IP addresses are added at internet layer. Internet layer is also responsible for routing the packet because it uses routers. Routers operate on this. So routers basically routes packets to destination using routing protocols. It's like routing protocols, which we have already discussed in the last video. RIP, routing information protocol, open shortest path first. Which sort of protocols actually run on it? ICMP protocol is one of the most large protocol that which run on this. So, and this is a UDP protocol. Please remember UDP protocol. The protocols which run on internet layer are always UDP. UDP, user datagram protocol, and as you know, UDP is connectionless. ICMP protocol, we have already talked about it. There are two main utility of ICMP, internet control messaging protocol. One is called ping, second is called trace route. Okay, so this is basically all about chapter number 5. We have discussed TCP IP protocol in detail. We have also discussed the SYN protocol. If there would be any questions, please do bring it up in the class. We will discuss them in class as well. Okay.